Hello everybody, welcome to another video of the Openthread 101 series, and in this video I wanted to give you a bit more information about the IP version 6, since it's used in Openthread a lot, and you will see a lot of different IP version 6 addresses if you want to look at packets using Wireshark, or in general it's a good idea to know IP version 6 if you want to work with Openthread. So as a resources, there are two links that I want to share with you. So one is from the Openthread. Here they give you some information about the usage of IP version 6 in the context of thread or Openthread, and yeah, that's also gives you a bit more explanation about what is rlog6, and yeah, it's I think a really nice started location to get started. Another link is this IANA entry for IPv6 multicast addresses. So here you would see the list of all the different IP version 6 multicast addresses, and if you remember, we were seeing this one as well, and this one as well, where we were seeing in the Wireshark captures. It was used with MLE, so these are the multicast addresses. This one is, you can think of as a broadcast address, and this one is for routers only, and these are link locals, so they are, any router is not forwarding, but these are only meant for devices that are in the immediate range of our thread devices. So in general, IP version 6 has 128 bits, and those then are divided into 8 groups of 4 hexadecimal digits. So 8 groups, 1, 2, 3, 4, 5, 6, 7, 8, and each group is then separated by a colon. And IP version 6 are less human readable and a bit difficult to remember, but you can have some kind of simplifications to shorten these addresses. For example, let's suppose an address is 20010db8, and then 000 and 0000000 ff00004283229. So that's a really long address, it's a mouthful. So that's a full address, and if you want to simplify that, then what you can do is basically you can leave out the leading zeros, so this address can be simplified into what you see here. So 2001, and then this leading zero is not written, so db8, then all the 4 zeros become only 1 0, all these 4 zeros become 1 0, all these 4 zeros become 1 0, ff00 remains the same, then the leading zeros are gone from the 42 as well, and 8329 then becomes the same. So then this address is a bit shorter than above. And further, if you have multiple sections of zeros, then those can also be simplified and can be shortened and written as 2 colons. So for example, here we have 3 sections that are all zeros, and these are all in together, so all next to each other. Then we can replace them with these 2 colons and then the rest of the address. So in this case, the address would become 2001 db8 colon ff00428329. And these 2 columns mean that any sections that are missing are basically zeros. So if you have 8 groups, then in the last address we have 1 group, 2 group, 3 group, 4 group, 5 groups. In total we have 8 groups, and here we have written 5 groups, and here we have 2 columns, and these 2 columns then mean that the rest of the 3 groups are zeros, and these are placed in this location. And we can have this double colon only once. So if let's suppose you have 3 zeros here and maybe all zeros here, then you would have to just use the double colon only once, and usually it's done in the middle. So that's how you would shorten IPv6 addresses. And then there are some special IPv6 addresses that you would want to know. So, and I have written their IP version 4 counterpart as well. So for the loopback address, we have : 1. So if you remember, you can replace all zeros with : and then 1. So this address is basically all the groups are zeros, and the last group, which is on the rightmost side, has 0001. So this is the address this is the shorthand form of this address. And in IPv6, IPv4 world, this address is basically 127.001, or localhost address. Then the unspecified, or for all addresses, we have an address which is all zeros. So in IPv6 world, all zeros, you can shorten them into double colons. So this address is basically contain all zeros. All the 8 sections in this address are zeros. And the IPv4 alternative is then 0000. For link local addresses, we have the group which is or the network part which is specified for link local addresses is FE80, and then : so, and then 16. So that means this address, like FE80 and then all zeros, network address is specified for local addresses, and this 16 is the network part. So that means that the 16 from the left side starting 16 bits, or this part, so FE80, is then the network part. So basically all the local addresses would have FE80, and then the rest of the address can be whatever somebody needs. And the counterpart here is the local address that you see in the IP version 4. So 192.168.1.1 has /24. So that means that this byte, and this byte are part of the network address, and the last is for host. Here, just these FE80 is part of the network, and the other are for host. And in a lot of locations, you might see that some hosts or some networks would use something like FE80 and then maybe 1 or 2 more. And in that case, then you would see that this part can become 32 or 64 or something. So in that case, then they use a bit of a longer prefix for the network part, but at the minimum it should be 16. Then for the global addresses, the prefix is this. So basically the 20 part are reserved, and that is the network part. So any global address should start with 20, and then the rest can be something else. And this is how we identify global addresses. The alternative to this one would be your public IP address. So not your local one, but your public IP address, or the IP address that it is assigned to your router. And here I have a star, because this address would come from a DHCP server or somebody who would provide your device with a global address. And if your ISP does not support, then your device would not get an IPv6 global address. So this address is usually allocated by somebody, or you can configure it manually if you have it. But just like you see here in our cases, we have the local address, and then we have the mesh local addresses. In this case, we see that there are 3 addresses. So this one is the mesh local address. This one is the rloc address, but this is also can be used within the mesh network, and is usually used by the network or by Openthread for communication. And then we have the Anycast locator address, which is also a mesh address. So all these addresses are for the internal use within the mesh. And there are a special class of addresses called unique local addresses. So these addresses are basically, this is the prefix for these, and they are used within the network. So if there is a mesh network, then these addresses are can be used within the network, and if a packet is being sent to these, then routers within the network would route these traffics as compared to the local one, which is not routed by the routers at all. This one would be routed within the network, and you can think of these as similar to 192.168 addresses, because these addresses, routers also route them within the network and don't send these traffic that is targeted for these addresses outside of the network. 192.168.0.0 or these kind of addresses are here to solve the problem of the IP version 4, where we have the not many addresses, and that's why we have these addresses behind network address translation or translator NAT. That is not the case with IP version 6. So that's why we only use these addresses in IP version 6, just to ensure that the traffic does not leave the network boundary. So if you want something that should remain within the network, then you use the mesh local addresses. Just like I said, I will repeat, so these two addresses, the above one, are usually used by Openthread or some implementation for users. We would use this mesh local address. And on the next slide, we have again a bit more information about these addresses. The link local address, the mesh local address, and then we have three types: routing locator and Anycast locator. And just additional information about the routing locator is that it has this FE00 and then the rlog16 there. So if you look here, you have FE00, and so both of these are then locator addresses, and then the last part is, when the last part is the rlog16, then that is a routing locator, and when the last part is FC some number, then that's Anycast locator. And then the other one, the unique local address, we talked about that in the previous slide as well. And for global IPv6 address, you usually get this from your ISP, and in IPv6 you might get a bit more addresses than just one, so then you can use them and assign further addresses. But I don't have too much experience with using this within ISP, so that's my knowledge there is a bit limited. But for devices to assign themselves addresses, then there's the Slack method, and this method is also used to get local IPv6 addresses in the local networks as well. DHCP, same, so it can be used to get the local addresses as well, and also the global addresses. And you can also then assign these addresses statically if you know what you are doing. Then here is just a sample from the operational dataset and the IP addresses from the two devices that we have. So if you look here, the mesh local prefix is then 64 bits, and that means that the part till 2077 is the mesh local prefix, and the part afterwards is then the device IP address. So in this case, this is the rloc address, and this one is the mesh local address. Here again, the same prefix we have, and then the local link local address. The link local address, the last part usually comes from the extended address from the device, and the extended address, you can think of it as like a MAC address of this device. I will show you how to see that in the next slide as well. And then you have the other three addresses here. So if you go to the next slide, there is one thing which I wanted to show you is a utility called OT-debug, and this usually gives you it prints a lot of information on the screen, and a lot of them is useful. So let's go to our devices here, and if we go OT, let's state here, so that's device is leader, and here OT state here, so that device is router. It's clear. And if you do OT-debug on the router, then it basically prints a lot of information, and some of them are the IP addresses, the IP, some addresses, the channel, the PAN ID, the extended PAN ID, and you can also see some other information, and here you can also see what neighbors this device has, what routers, the list of routers that this device has. Since this device is a router, each router has a list of all the routers on the network. So currently it has two members in this list, because in this network there are two devices and both of them are routers. And some other information are included here as well. And if you do the OT-debug here as well, you can also see a lot of information. And yeah, it's just sometimes it's difficult to remember a specific command for everything. So this is just a very general general command that gives you a lot of information. I think for this video, this was enough, and I hope it was not too complicated or too disorganized. I usually don't have a fixed script for these videos, so I just have some kind of plan in my head, and then I just go with it and see what happens. So I hope these videos are good enough, and thank you very much for watching, and we see you in the next video.